Group debugging. It's like pair programming, but larger. Let's figure that out as a group. Okay, I have no mic, so I won't yell. So this time, this is my last talk for this thing, and the goal of this talk is for me to convince you that workflows are actually not completely useless. How many people have actually tried to use workflows, ignoring as your automation, have tried to use workflows for something?
Also as a main?
Yeah, but just workflows in general. How long did your workflow run? What was the running time of your workflow? Anybody? 2 minutes? 5 minutes?
5 minutes, maybe.
They weren't workflows.
About 20?
20 is starting to be a workflow. If it runs less than an hour, it's probably not a workflow. Because if you can recreate what you're doing in a minute or two, why take on the overhead of a workflow?
Because SMA doesn't allow anything else.
Yes,
Yeah,
and that's being changed. You know that you can now run scripts in SMA.
Yeah.
So, or as your automation. No, no. Oh, and interesting aside. So the core DLL in PowerShell is System Management Automation, or SMA. And so when the workflow guys started talking about SMA, we're like, what? So we were very confused for a while. So as always, the agenda, background, some definitions, an overview of the workflow architecture, so you can understand why it's slow, and then the conclusions and questions, and maybe a demo or two. So one of the things that I don't know if we've ever really discussed in public is that every PowerShell release has sort of had central themes to it. The first release was obviously like just get it working, and get it working so that Exchange could use it. The second release had really prominent themes. Modules was one, and remoting and constrained run spaces. So this whole notion of themes drives, it's kind of like a user story, right? It kind of drives what you're doing. In PowerShell v3, the theme was multi-machine management. And so that was when server managers could start to manage multiple machines. And the goal was that we would have, so PowerShell is good for managing a machine or several machines, but it's not good for doing things over a long duration. And so we wanted to, well, we actually looked around and we saw that everybody and their brother was doing workflow in PowerShell. And it seemed like, the workflow idiom seemed like the right idiom. We talked to the workflow team, which, by the way, Windows Workflow Foundation is properly shortened to WF, because the World Wildlife Federation got really upset with it. Right, so our theme was all about using one machine to manage a lot of machines, multi-machine management. And that means that you have to optimize the resources that you're using. So another thing that keeps coming up is workflows versus desired state configuration management, DSV. No, that's not right. Yeah, no. Real-time spell checking. Thank you. That's why he does my spell checking. Like, he's got this like twitch. So the thing the theoretical significant difference is how monotonicity works for both of these technologies. Workflows are monotonic in time. They always move their state forward in time. But it has multiple states, and it never goes backwards. DSC is monotonic in state. It always moves towards one final state. When you're writing a DSC configuration, there's a lot of people who look at it, they go, well, it's just kind of like imperative programming because you have dependencies. But it's not. It's a representation of a single final state. And that's why you can't have something that says the registered key should be 3, and then it should be 4, right? Because that's not one state. You need to be able to transition through various states. And so they're very complementary technologies, right? If you need to transition, if you need to be in a state where the reg key is 3, and then you need to be in a state where the reg key is 4, you can't express that in DSE, but you can express it in workflow. And that's something that we haven't really talked to people about. Internally, we talk about this notion of phases in configuration. So you have a phased deployment of your configuration. The workflows, a bunch of things that workflows are not. They're not PowerShell script. And so right up front, mea culpa, we did a bad thing, sorry, our bad. We made it look almost exactly like PowerShell script. And thank God Kenneth at the last minute said, no, you have to use something besides function. You have to at least use the keyword workflow, so that at least there's something that tells you that it's not a PowerShell script. Because it has radically different semantics. It's lexically scoped versus dynamically scoped. It's statically typed versus dynamically typed. I mean, it's just, they're as far apart as you can almost get in the language space. And making the two look together was an egregious error on our part. In my opinion, it should have looked like a lot more like DSC. That you would have sequences and parallel sets of operations in order. And I may convince somebody to let me still do that. Because it becomes a really nice natural extension to DSC. Do these things, like move to these configurations and do this over here. And if you look at the JSON ARM templates, they're kind of like that. So PowerShell script is not PowerShell script. It's not intended for small operations. Please don't use it to read reg keys. I see people writing sub workflows to read a reg key. The overhead is just unbelievable. So don't do that. And this was not designed to call each other. This is kind of funny because for the Azure automation scenario, you want to have libraries of workflows that call each other. But in practice, the way it works, because it's designed for static compilation, is really you should only have a top workflow and everything else should be a script. So again, if you find yourself in a situation where you have workflows calling workflows, you're probably doing it wrong, right? It sort of feels logical, but in the end, you'll pay for it. And it is a big problem for Azure automation because of the way it works, because everything is statically compiled. If I change something, like if I change this thing, if A calls B calls C, if I change C, I don't have to just recompile C. I have to recompile C, B, and A, because they all have hard references. Every time I recompile them, it's a new type. So A points to a type B, B points to a type C. If I recompile C, now I have a type C prime, which means I need a type B prime, which needs the type A prime. And so if you have a lot of workflows in this fan-out thing, then you get combinatorial explosion of compilation, and it gets really slow. And so that's one of the reasons why sometimes the startup on AA is really slow. We are working with them to try and fix that, because we try not to be evil. So let's do a little bit of timing here. This is a very simple workflow. It just gets a list of the files that are in Win32, all the DLLs, and just counts them. Very, very simple operation. Let's see if I can actually manage to find my example. Or worse yet, I'm going to try to cut and paste. Do not try this at home.
And do duplicate.
Why do you use a backtick count?
Pardon?
There's a backtick.
That's an error. Let me fix that. Thank you. Yes. Well, that's another. So I have the example actually in place here. Emergency backup talk. Yeah. So there are two examples: timing the script, and then timing the workflow. And they're just doing the same thing. So let's run both of them.
So, Bruce, we are not seeing the same thing using.
Oh, probably not. You should be seeing, you're seeing these examples, right? I'm not switching over to actual code yet, so you don't get to see me fumble around in real time. So I'm going to run these examples now. There. So this is basically the same code that I had in the slides. So let's run that stuff. Wow, this is even worse. Again, when the disk is not hot. So the other one we were sitting there and waiting 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 and waiting. Here it took like less than a second, or a little over a second, to do the same operation, to enumerate all the files, and then just do a count of that. So I was going to show you that it's like orders of magnitude difference in performance, but it was even too slow to show you that. So don't do small operations. Use workflow carefully, use workflow wisely. The one thing that you do get from doing the workflow is you get a whole bunch of extra tracking. So I like to call it managed execution. Maybe that problem. Let's go back to the slides here for a minute. Okay, go back to the example in a minute. So we just talked about how bad it is to do small operations, and yet we have turned every single freaking commandlet in standard libraries into an activity. Why did we do that? Well, it seemed like a good idea at the time. Sometimes it's right. I mean, sometimes you do need to do like some stupid little operation that you don't want to wrap in a script right at the end of something, set a reg key or whatever. But for the most part, it's a really bad idea. You should be using large blocks of code, either inline script or, and a good pattern that I think people should use is you write your blocks of code as functions higher up in the in a script, and then you use the workflow to orchestrate them later on. But part of the driving factor of this was the solemn vow that Jeffrey talks about, that when you learn something once, you'll never have to learn something different. Right? That works most of the time. In this case, it was a mistake. Yes, so it does keep the solemn vow. It may keep it a little more than we would really have thought necessary, because different things should be different. And the big learning that we got from the entire workflow project, and if you ask Hemant about this, he will tell you no frickin' magic. There's so much magic in workflow. It hides the details. You don't know what's going on, and it makes it hard to use. It doesn't mean it's not possible to use it. It just means that sometimes we get in the way of you figuring out what the heck's going on. So here's the actual internal workflow architecture. One of my lovely hand-drawn arrows, because last night I got tired of using ends are awesome. So this is plain old regular PowerShell, right? So you write your workflow, it compiles into PowerShell, it compiles into an AST, and it just sits there until you call the workflow. At that point, the engines of creation come into being, and the AST gets regenerated as this enormous XAML document. So the AST is not terribly small, but it's not huge. But it becomes an XML document that is like freaking enormous. Yes?
You can actually watch the XAML definition when you run get commands against your workflow.
Yeah, you can see the XAML definition. Yeah, it is actually available as part of the metadata. I would dump it out, but I don't have that much time. So, I mean, to watch the entire stupid definition come out. And so you take something that's relatively small and you make it really, really big. And it's an XML file and it's a text file, and XML, as we all know, is very slow to parse. And then we pass it off to the workflow engine, which takes that thing and then converts it into a pile of objects. So now we've taken a pile of objects, turned it into a pile of text, and turned it back into a pile of objects. Not fast. And then okay, now we're executing. It's being executed by a completely different engine. The workflow engine has nothing to do with the PowerShell runtime. All it's doing is it's sequencing the set of objects that are part of workflow, not part of PowerShell. So they're completely parallel execution engines. The workflow execution engine is designed to do a couple of things. The most important thing that it's designed to do is to manage its state. So it can take itself out of memory. Everything that's in the workflow graph has to be serializable. So, for example, if you're in a function calling a function in PowerShell, we can't serialize that to disk because it's the actual machine stack that's being used. But workflow is a state machine. It maintains everything in user space and user memory, and so it can serialize and deserialize all that state. And that's part of the reason why it has all these restrictions. By restricting what you can do, it allows it to do other things that you couldn't do. And that's, you'll sort of see that over and over again, is that workflow is not more, it's like DSE, it's not doing more, it's doing less. Right? It's restricting you from doing certain classes of things, that enable you to do other things. You can't do everything that you can do in PowerShell that you can do in DZ. Can't do everything that PowerShell can. By design, that's a feature, right? So using workflow like PowerShell, in theory you can do that, but it just you're kind of like clashing with what it's really supposed to do. And then the last phase is, okay, we have a run space over here. If anybody was in my talk yesterday, we talked briefly about run spaces. They're places where stuff runs. Right? So it's a space where you run stuff, run space. Not very hard. And so, run space, workflow engine, and now we come down to here, right? So the workflow engine, I said, is completely different, which means it can't run PowerShell. But wait, all of our activities are PowerShell. So what happens? Well, we have what we call the activity host. Every line in a workflow script turns into a workflow activity, which is run by the workflow engine. The workflow engine, the activities, however, are built out of PowerShell. So the workflow engine uses this, what we call the activity host, to take your activity and then turn it back into a PowerShell run space. And there are a couple of flavors of the run space. I actually meant to put one more picture up here. There's the in-process activity host, where things are slow but not ridiculous. And then there's the out-of-process activity host. And if people notice that there's a new API, you can now create an out-of-process run space or run space pool. That was added for that particular scenario, where you can run things out of process. And why do you do that, right? It's like really slow. Well, the obvious reason is for stability, right? If one of the in-proc run spaces crashes, then it takes down your whole process. If you run in an out-of-process run space, it crashes, it doesn't, the parent process is aware that it crashed and it can report it as an error and proceed. But it means that there's serialization everywhere. And that's slow, right? So again, we're back to that slow thing. Workflow trades off reliability and consistency against performance. So you want to balance those two things. Use the right tools for the right job. And then the crux of workflow is system, like Orchestration, right? The name of the product was Orchestration. In Orchestration, you don't want, individual steps should take hours, not minutes. A workflow should be running for hours. It shouldn't be running for a few minutes, because there's no point in doing that. If you can reproduce your effects in a few minutes, then just do it, right? There's no point of having it stop and do a checkpoint and then resume and continue on if all you've done is save 30 seconds, but you lost 40 seconds because you're checkpointing. So again, judgment matters. And then the logic should be simple. Some of the best applications, if you've seen the designer, the Opalus designer is very restrictive in what you can do. And the way it works is you install a pack. And that pack has a specific set of tools that constrain what you can do. It's basically it's a domain-specific language for performing certain types of operations. One of the groups that we talked to very early on in Microsoft was a group in China who eventually started using they were building a lot of VMs. And they were using MS-Build to build the VMs, but MS-Build doesn't model monotonic state and time very well. So they switched over to workflow. And so what they did is they ended up they took the workflow design and they wrote a small set of steps that you could compose linearly. And, I want this workflow, I want this type of machine, bang, I want this on this machine, I want this on the machine, I want this machine, start this process, these are my validation tests. And it was really, really good. It was, because it was very easy for people to create what they needed and to not get it wrong, because they didn't have a lot of choice. I was visiting, I think, State Farm a few years back, and they had a similar sort of arrangement. They had this workflow engine that was nothing but a monotonic series of steps. And different people in different teams own different steps. The networking guys could change the networking steps, and the VM guys could change the VM steps. But it was all just sort of one big workflow, and people could pick and choose steps and put it together. And they loved it. And, I talked to their devs, and I said, well, do you hate this? And they said, no, this is great, because stuff that's boring and kind of hard to get right now becomes easy and trivial to do. So there's a lot of value in that. The other theme that we were doing with workflow is what we called lights out management. Right. You're going to start something that's going to take 20 hours. You don't want to be sitting there going, okay. So the idea was to gather all the parameters at the beginning and then say go. Close your laptop, go home, have coffee, eat dinner, put your kid to bed, open your laptop and see what the hell's happened. But because of the way you did it, well, workflow ran on your own machine, so if you closed your laptop, well, it stopped. But you could, use WSMAN to run it on another machine, but if you close your laptop, you break the WSMAN connection and it would die. But you could use a detached connection, but that has a fairly short lifespan. So after half an hour or whatever the heck the lifespan is, it would die. None of these things are really what we wanted. Yes?
You can understand that it should be, if your workflow completes in a few seconds, it shouldn't be a workflow.
Right. Thank you. He's gonna get like editors, super guy. So orchestration. Remember, the conductor in an orchestra does not play any instruments. They are telling people what to do, and that was our scaling model. So if I want to manage 100,000 computers, which was my manager's, he wanted up his goal for me was to manage 100,000 computers with one machine. It seemed excessive, especially when we had no what did it mean? But the idea is that you don't do any work on the machine itself. You farm jobs off, right? So the workflow engine is just sequencing remote run space activities that run on the target machine. If that's all it's doing, it's just starting up a remote run space and then it goes idle, you can manage a lot of machines because you're not doing very much. You're just initiating a remote connection and then going to sleep. And your run space does that. You can go idle and it stops allocating threads. You can even have it removed from memory because it'll maintain the state. So it can be it can scale really, really well. The other thing is, so this is kind of what our vision was. This is a picture from way at the beginning of workflow when we thought we could we could like move the earth with a lever. There was going to be this mythical mid-tier, right? So I said, well, closing your laptop, you're running on your laptop, you close your laptop, it stops, you're done. You needed to have a place to run it, and so there was going to be this mid-tier that was PowerShell workflow. And the happy little guy at the top would say, start job, and it would run my workflow automatically on the mid-tier with like the run as elevated credentials or whatever, and there was going to be RBAC and basically all the stuff that Azure Automation is providing now, but we were planning to kind of like build into this thing, and we never even got close. But in theory, the architecture is you'd have the mid-tier, it would be managing a whole bunch of machines, and you would have this file share with which does all your checkpointing and logging and stuff like that, which then allows you to actually do quite a simple HA. Right? If you have a shared file store, then you have a secondary machine, and you can just bring that machine up, pointing at that repository, and it'll just resume those workflows because all of the state has been serialized to disk. So you can do failover fairly easily. We didn't do that. I mean, you can do it yourself. You can do it manually. You can nuke your one machine, fire up another instance of the workflow engine, pointing at the same repository, assuming that you're not encrypting it with machine credentials and stuff like that, and it'll just work.
Yeah, but this is actually the architecture of SMA or Azure Automation, right?
Yes. But
We're just ahead of a time, right?
Well, but our goal wasn't as ambitious as theirs, right? They want to have a full user interface, logging, reporting. I mean, there's a lot of features in Azure Automation. The logging and reporting is huge. The very first thing, when we showed the Stack Overflow guy's DSE, the first thing he said is, great, where's the logging? Right, and we didn't have an answer. And that's really kind of the thing, is you have a large volume of data that you need to interpret that data to be able to understand what's going on. So that's where I run out of slides. And I was trying to get this example to work, but it doesn't. But working on my machine with them. It's extremely busy. Did anybody come to my session yesterday? On where I was showing some of the logging and debugging stuff. So one of the problems we have over and above all the other ones is that Workflow does a wonderful job of tracking progress. It actually has there's a component in the Workflow engine, there's an active native component called a tracking participant. And that tracking participant is exactly there to track what you're doing. And so anything you feed to the tracking participant should get logged. Now, of course, we don't do that. We just write stuff out through standard output and standard error. But we do write a progress record, begin and end, for every single activity that gets executed. Those appear on the screen and they vanish. And so what I've been trying to do with this example that I was working on yesterday before my machine turned into a pile of goo, was in the same way I was using it to track scripts, I can track workflows. Ooh, maybe something good had happened. So we have, this is the same basic thing that we were doing before. Brief recap. So I'm just using the PowerShell API to run a PowerShell program. I've set up event handlers to capture all of the events that are written to all of the event channels. I write them into a concurrent queue, and then I have a separate thread, a task on a separate thread that every 200 milliseconds drains that queue and writes it to disk. So the overhead of writing to disk should be relatively minimal because it's being batched. And let's try that thing. Actually, it's already running. Oh, I think it's happening. I think it's logging enormous amounts of data to disk. Yes, it is. So pretend I was showing you the code. If you run in this, and so this little host that I'm designing addresses a couple of problems. One is it addresses saving all of the, I hit Control Alt Delete, so it's leading to think I'm logging out.
Next stop is that.
Yeah. Wow. I think my disk is going to be very full in a second. Where was I? Oh yeah. So the goal of this host is, first off, it's not WSMan, it's not PowerShell. It's a standalone Windows host that will not terminate. It'll run for as long as it is allowed to run. Second is that anything that gets written to any of the queues gets logged automatically. And so you don't lose these progress records. You don't lose all this information. And if you turn on tracing, you'd also get the trace information going into the log. And now you have a way of running workflow independent of any of the PowerShell hosts with reliable logging. And say if you need to start it, then you can start it from the task manager with a particular set of credentials. And now it should be possible to use workflow properly. You have a machine where the task manager is being used to like run the jobs, run the workflow jobs, using this little host, logging information, and then you just disconnect and go home, and then do a tail dash up on the status of the job. And once I get this fixed and my machine starts blowing up, I'll make sure that the code goes out. Yes, that's using all my memory. Stop. So I will send around the updated code. If you saw it yesterday, you saw it was running. Today it's not running. But that combination of features of using sensible use of the features in understanding and sensibly using the features that are in workflow means it can be very valuable. But if you use them like they're just PowerShell, you're screwed. Sorry, I'm sorry. You're in trouble. Be more correct. Wow. The machine is so gorgeous. I bet this It's probably now hung trying to do logging or something.
I see it was already open.
Yeah, I was expecting to switch to it. So this is the example of the pattern I was talking about, is that I have a workflow down here that has a set of workflow steps, 1, 2, 3. But I'm using either inline script activity or I'm using a function. The function's in the same file as the workflow that's using that function. It will automatically synthesize an activity for it, and then I'm using it to call a configuration. So that's using the mixed mode monotonic in state and time. And then if you run this under the little host that I had, you should be able to get all of these messages. If you write, DSE writes to the verbose stream. So everything, all the messages that DSE writes will get captured into the same set of logs. So you'll see all of the workflow progress logs, all of the DSE progress logs in context with each other. And so you should be able to debug. And if you instrument your code with write verbose or write debug, again, you should see all that stuff in context, tagged in such a way that you can filter. In fact, you can even put it into Lucene and do analysis. So that's my advice on how to use workflow. I think that workflow is a very useful tool when it's used appropriately. And now we'll do a question, because that's a question.
So when you're using the inline script and you use verbose messaging for debugging purposes, because there's no other way, right? But
No, that's write information.
Sorry?
Well, write debug is for debugging, and write information is for, so that how many people know we introduced a new stream, the information stream? Right. How many know what it's for? Right. Well, but we were never very clear about the purposes of the stream. So verbose is for the end user. It tells them, it's supposed to be used to tell the user something more about the operations they have performed, copying a file or whatever. Debug is for the developer, is supposed to debug things. And information is approximately equivalent to the analytics stream, in that it's stuff that the operator should know about. The person who's consuming, not the developer, not the end user, but the person who's sort of managing that technology. And so that adding the information stream filled in that missing hole. And progress, one of the things that I like to do with progress, because we use progress to mark the begin and end of every activity, but progress records generically get discarded in all of the hosts except the one I just wrote, or actually in my workflow designer. The ability to see all that stuff is quite useful. See if my workflow designer still works. It's another one I have to put on GitHub. Typing, what did I do? Is anybody running 14.3.22? The most recent fast build?
Yeah.
A pity, yeah. Especially the console got all screwed up. It ignores your console default settings, and you end up with this tiny little console. And then you have to go back and change it to say, oh, I want more than 40 lines of history and stuff. You go, how did they mess up? Especially because the console is a big deal with the subsystem for Linux thing. So Earth is quite a while back. This is a rehosting of the XAML designer. We'll just write a very quick workflow. So this shows you the presentation. This is the piece that I actually wanted to show, is all this metadata. These are the progress messages that tell you everything that's happening, what machine you're on, what you're doing, when is it happening, what's the source line of the script, all that kind of stuff, encapsulates the actual operation that's being done. And just having that, we do the same thing in DSC. We encapsulate begin and end around each activity. So having that capability, I think, really helps being able to debug your stuff. It just gives you the context. We were having a discussion about log messages with somebody this morning about how developers suck at log messages because they never think about context. They look at what they're doing, they have context in the code, and so they write a message that makes sense to them rather than looking at it from the user's perspective. And so I insist that when developers write log messages, they write log messages for a reason. That is, they have an actual reason to log something. They're not doing it because it's a checkbox item. And when they're doing it, they do it with context so that it makes sense. They ignore me, but you know, whatever. I'm going to open source this thing finally. And this is the XAML that gets produced by the designer. It is significantly smaller than the XAML that gets produced by PowerShell because there's a lot of stuff gets injected into the PowerShell XAML to give you PowerShell semantics that you didn't really want. So that's everything I've ever wanted to say about workflows. And a great deal more, actually. So I'm open to questions, or are you run free and get coffee, or do as you will. Any questions? Any more questions? We have one. So next time you go and do workflow, you're going to think about what you're doing and why you're doing it. Like if you're using SMA and all they're giving you is workflow, then do one big inline trip activity, which is pretty much what people do.
Which is a disaster. Because SMA, the current version, does not officially support WMF5. And with WMF4 we have this
It supports WMF 5.1, which is the current supported release.
Sorry?
It supports WMF 5.1, which is the current supported release.
That will be the 2016 iteration, I guess.
That is what's out there now. In fact, they released, before we released WMF5 and then clawed it back because we had a stupid bug. A stupid but very damaging bug. And then we re-released it. But actually, Azure Automation was ready for WMF 5.1 before we were. So if you're using WMF 5 advanced to 5.1, that is the supported release. I think Jeffrey talked about that.
Except when we log a ticket at the SMA team, we have a problem with SMA 2012 or 2 running WMF 5.1. So it's the other way around.
Right.
You may support the product, but the product doesn't support WMF 5.
Oh no, they actually released ahead of us. There was
Yeah,
some
that was
stuff in.
Azure Automation. I'm talking about SMA.
Oh, SMA. Oh, yeah, I don't think about that.
So I'm true.
That's nothing to do with cloud. So that's a good thing. I'll see if I can, because SMA team and Azure Automation team are sort of the same team. Joe Levy, by the way, is a guy who's a PM at Microsoft. Send him all of your love notes and brickbats. He's developing extend.
So where can we find examples of good workflows?
I'm going to try and provide a couple, well, along with the rest of this material. But just my guideline was as I showed in this example, we'll have this example open somewhere.
I think the PDT is a good example of a good workflow.
Yeah, so here's an example, right? So here I have, my logic is split out into configurations and functions and inline script activity. I think actually you're better off putting it all into a set of functions and then just calling the functions one after another. Oh, there's one other little thingy that I was going to show that is almost entirely unrelated. It's related in the sense that DSC and it's not kind of an alternative approach to doing authoring of things like workflows because it's a much more constrained environment. Okay, so this was actually something I put together for doing DSC, but it would work just as well for workflow. So if I want to do something like the file resource in DSC, I click, I add the resource, I fill in some value. Add it to my configuration, and then it's configuration. And so poof, I've generated a DSC configuration. We can do the same thing for workflow, right? Have the list of workflow activities show up in this list, and just be able to, like, you publish a module, you import the module into an environment like this. One of the things about modules is always a way of defining essentially a DSL, as you understand it well. Right? A set of activities that work together that may come from different locations, but these are the set of activities that all work together. So you could have a create VM, configure VM, start VM, test VM. There's a whole series of operations in a workflow. And then when somebody has to go and configure that stuff, they can pull up a UI like this and just do point and click. I'm sure David can do a much prettier UI than that, but it's again, this is something I put together in an evening. Once you have that structure in place, it's really surprisingly easy to build on top of those structures. So I highly recommend being inventive with how you use things, and think about what you're doing rather than looking at some example that somebody says is really cool. Because I think I bet we have a lot of bad examples with workflows where people are doing get red key, write three characters into a file. We should have best practices. I am about to write the chapter on workflow in my new book, which is going to be largely based on the content of this talk, with a focus on how to use workflow well. So if you're on the meet, let me know if I'm hitting the mark or not. That's it? Oh, one more.
This is kind of a dumb question related to, you mentioned write information.
Mm-hmm.
You use write information to get things into the information stream. How do you
Yep.
see the contents of the information stream?
So right now the information stream, in the default host, the information stream goes to the verbose stream, which is kind of bogus. But we did it that way so we didn't break everybody's hosts. But in the example that I have, I actually capture the information stream, tag it as being information rather than verbose, and then write it to the log file. So there is an actual, there is a stream associated with the PowerShell object that the information will be written to. But in our hosts, in the ISE and in the console host, it just merges that with the verbose stream right now.
Is it concatenated in a way that, okay, I've been throwing things into the information stream all day, how can I see what's in there?
You won't be able to distinguish it. I'm quite certain you won't be able. It'll show up as a verbose message. So information stream came from Jeffrey and Lee Holmes and I were going for coffee, and we were talking about this topic, and we said, we should have an information stream because we did all this stuff, we did all that stuff, but we really didn't, this notion of an analytic stream, we just didn't do that. And Lee said, oh, okay, and about 2 hours later we had an information stream. But for compatibility reasons, right, we had to make it work with the existing hosts. We have a solemn vow not to break software as well as not to break people much. Wait till you get pattern matching in PowerShell. So, yeah.
But I want to just talk about the differences when we work in Azure Automation
Mhm.
with Rhombus and we want to nest it. Then we need to use a little bit different syntax
Yeah.
compared to workflows in a PowerShell console.
Right. Yeah, they do a bunch of, actually, it's kind of funny. They do a bunch of stuff to make workflows look more like PowerShell in AA. And yes, they have some stuff, because this recompiling thing is just a killer because of the way they work. They use a technology called drawbridge, which is a single process virtual machine to run everything in. And they take a while to spin up, even though, I mean, they're less than a real VM, but it still takes a while to spin these things up. And so they have a lot of things that they're trying to optimize. Containers, I think, once we get to the point where they can use containers, that'll help a ton. Maybe VM containers. But yeah, so that would be why there's some things that they've done that are specific to them that are necessary to make their infrastructure work. I don't know anything off the top of my head, but I do know that they've done, like we spent a long time with them working on the AST, so they could go in and rewrite the AST to make it more PowerShell-y from the perspective of their users.
Because now they support PowerShell script runbooks and the PowerShell workflow runbooks. So you need to be careful, like when you nest those runbooks, there are different rules for
Yeah, well,
how you
that they
call them
support-
actually.
yeah.
So
Now that they support script, I think that the need to have nested runbooks should just vanish. The reason it's so the reason that we did nested runbooks is because of the way scoping and tracking happens, right? So if you have a nested runbook, then it'll sort of seamlessly flow into the whole tracking thing, which is great, but it costs you a lot. Whereas if you're just calling a script, you're going to get the script traced the way a script is traced.
Yeah.
So,
But if I follow your best practice here to kind of create a few functions and then orchestrate them inside of a workflow, if I look at the Azure Automation, so I have, for example, 5 PowerShell script runbooks,
right.
and then I can write PowerShell workflow runbook that will orchestrate those 5 PowerShell script runbooks, right?
Well, sorry, I'm a little confused by what you're using the term runbook for. A runbook is a workflow.
No, not in Azure Automation anymore. They use a runbook as a, I don't know, now for, it can be script runbook or workflow runbook.
That makes no sense at all.
They used initially runbook to make the connection to orchestrator, right?
Okay, so we will ignore what they call it and either script or workflow. And if you have a bunch of scripts and then you use them in workflow.
So I can have 5 functions,
Yep,
PowerShell scripts,
yep.
and then I can write a workflow
Yep.
that will call those
That
5.
orchestrates those things, right?
Yeah, so in their case, that will be nesting. So I will actually nest those 5
Right, but it's not,
inside of a,
but it's not nesting in the same way that, like, to nest a runbook, you have to generate a DLL. You don't have to do that with scripts. So it's a much more lightweight notion of nesting.
That's what SMS is. They generate a DLL.
Well, they do for nested runbooks because you have to. I mean, we do that too. Like we gave them the technology to do that, but it's because of the way runbooks or the way. So you can do workflow with loose XAML, but it's really designed to be a compiled environment. An activity is a DLL. A workflow is an activity, therefore it's a DLL. And if you want to get the correct lexical semantics, you have to. Everything gets compiled into its own namespace. So that the variables that are defined in one workflow are not visible in another workflow. You can actually tweak it and have workflows call workflows, like a loose XAML workflow call a loose XAML workflow, but the problem is that the variables all flow up, right? It's like dynamic scoping. In fact, it's just like PowerShell. And so maybe that would have been the right idea, but as it turned out, that's not what we did. So in order to get the correct lexically scoped set of semantics, we have to generate DLLs. Maybe we don't anymore. I actually was talking to the foundations guys a little while ago, and they may actually now have a mechanism where you can have loose XAML calling loose XAML that honors the lexical scoping semantics. I need to follow up on that. Because we haven't done much with it since it was released in 3. But I still maintain it's useful. We need to go back and revisit it. We got so distracted with DSE in version 4 that, I mean, DSC version 4 was a product that was, from conception, like from first check-in to delivery was like 8 months. It was the fastest release cycle of any, like from no product to a shipping product. I've never seen anything like that fast in Microsoft. But of course it was a minimal viable product, barely. And so Windows 5 spent a lot of time fixing all the stuff we didn't get done in 8 months. But I was very pleased to see that Microsoft could do that. I would not have believed it. I would not have believed that they could ship it anything under 2 years. But we did. It was awesome. And now we ship new DSC resource packs every month or so. And the Azure extension is being published. You know, number of like 10 times or something like that in a year? Because it's a service-based thing, we can publish whenever we want. I know that the OMS OI guys publish many times a day. So,
but for DSC extension, we need a little bit better documentation about changes. So like.
Oh, you want documentation?
No, just like a
Where's Trevor?
change log kind of thing. Not,
Yeah.
So like we fix bugs. Like, okay,
Mail Noberto. He's the man. You got his email?
Yep.
How do you have to have Microsoft? Yeah. Mail him. Make him feel guilty.
All those, I mean, there is that sticky blog post about releases, and very often it says like, we fix bugs. It's like, cool. What kind of bugs? I would like to know that.
Yeah, sometimes they're just like obscure, stupid little things that would take, the explanation would be complicated and it wouldn't matter. But yeah, I mean, you'll notice that Microsoft backed off the, we're going to ship stuff, but we're not going to tell you what's in it. Because
They should do the same thing as the DSC for Linux extension, just host it on GitHub so we can at least view the dev, right?
Yeah. Patience is a virtue. Hey, bash on Windows now. So, anything else? Everybody go up, right? Workflow, good workflows. Thank you very much.